Okay, so to multiply complex numbers, what we have is just like foiling a polynomial, or a binomial. So for this first one, I'll just get that copy down over here. Okay, so we're going to multiply the first, so that's 16. We'll do the outside, which is 12i. We'll do the inside, which is 32i. And the last, which is 24i squared. And then what you got to remember, well, let's see, I squared is the same thing as -1. So that's the same as 24 times -1. That gives me 16 plus 12i plus 32i minus 24. And now you just combine like terms. You combine the real number part. 16 minus 24 is -8. And then you combine the imaginary part. 12i plus 32i is what, 44i? And that's the best we can do with that. And is that one of the answers? Let's see here. What did I say? -8 plus 44i? There we go. Okay, so for the next one, let's see. Same kind of deal. You can even stop this and try this if you want. So I'm going to multiply 8 times 32, 4 and get 32. I'm going to do the outside. I get positive 72i. I'm going to do the inside. I'm going to get 32i. Then I'm going to do the last, which is 72i squared. And let's see if we combine the real number part. Let's see, first off, the I squared is -1, so that's going to become -72. 32 minus 72 is -40. Then we're going to add those two imaginary parts, which I believe is 104i. And there is the answer. Oh, that's 104i. All right, that's the one. Okay, now I included this last one, even though it's got a little more algebra here. That's how you just delete this, what I've written. So, when you see a binomial squared, which I want you to remember is to write it twice, and then you got to FOIL it. And we won't distribute that 5i through first. We could, but you would only want to do it through one set of parentheses, and that tends to get confusing. So let's combine these two to multiply these two binomials. These two other complex numbers that are binomials. So that's going to be 9. Now I hope you can get to the jump. It's -6i, and another -6i is -12i. And then -2i times -2i is positive 4i squared, which becomes -4. So 9 minus 4 is 5. So 5 minus 12i. And now I'm going to distribute that 5i through. So that becomes 25i minus 60i squared. And of course I squared is -1. So that becomes positive 60 plus 25i. And is that an answer? It looks it. So I hope that works for you. Now dividing complex numbers is just like trying to rationalize them. Let's see, you should have done a little bit of this before this, but in case you haven't, if I have, just so you relate it back to something you know, if I have 3 divided by the square root of 5, back in the old days, before graphing calculators and calculators, having the square root in the denominator was not considered great form. It was hard to calculate with. So what we used to do is we would rationalize it by getting rid of that radical. Okay, and so what we'd do is we'd multiply the fraction by a form of 1, which root 5 over root 5 does it, and that would be 3 square roots of 5 over 5, because square root of 5 times square root of 5 is 5. So that rationalized, it made a rational, put a rational number in the denominator, 5. If sometimes what happens is if you had a radical in the denominator, like 3 plus or minus 3 over 3 minus, let me not make 3 here, that way you won't be tempted to cancel. Let's make this 5. I got a radical denominator. How do you get rid of that radical? Here it was easy because you could just multiply by whatever the radical was. But here we got a binomial going on. And if you think back to the difference of two squares, if I multiply by this form of 1, and then I FOIL the bottom, I get 9. Then I'm going to get a positive 3 root 2 and a negative 3 root 2. Those cancel out. So then I just got to deal with the negative root 2 times positive root 2 will be negative 2. So the denominator becomes 7. And in the numerator, of course, what do I get? 15 plus 5 root 3, 5 root 2 over 7. And that rationalized it by multiplying by this difference of two squares pattern. Those are called conjugates because when you multiply them, you can get rid of the radical or get rid of the problem. Okay? When you're dealing with complex numbers, I is just the square root of -1. It's another radical. So to get rid of it, to rationalize this denominator, divide the complex numbers, as they say, we're going to multiply by the conjugate. So 5 minus 8i, 5 minus 8i, and then we've got a bunch of FOILing to do. Fortunately, in the denominator, that's very easy. That's going to become 25 minus 64i squared. And I squared is -1. That becomes 25 plus 64, which is what, 89? So the denominator is 89 now instead of this messy thing. So now we've got to FOIL the top. Let's see. So I'm going to get 5 times 7 is 35. We're going to get negative, let's see, what is that? Negative 56i, negative 15i, plus 24i squared. Which, let's see, I squared is -1. We get negative 24. 35 minus 24 is 11. And then we've got two imaginary parts, which is 60, 71, I think, negative 71i. And that is divided. Now they're just having you break it out into two. I mean, for these multiple choice questions, right? They're having you break it out into two. But that's the process. It helped us reason them out. So why don't you try this one, and then come watch this video, and I'll do my walkthrough of it. Okay. You know, one thing I was just noticing, some people will be tempted just to cross out those 3 i's because they're the same. I think they're done. The trouble with that is, if you think back to, order of operations, if I have 4 plus 3 over 5 plus 3, the real answer for that is going to be 7 over 8. If you cross out those 3's, you get 4 over 5, or maybe you get 5 over 6, depending on what you think you're doing. Definitely not the right answer. So you've got to follow the order of operations. So for this problem, what are we going to do here? So I got to multiply by the conjugate. So the conjugate of the denominator is 5 minus 3i and 5 minus 3. Okay, so now to FOIL this. On the denominator, I'm going to get 25 minus 9i squared, right? Because it's 5 times 5 and there's no middle term, so negative 9i squared, which becomes plus 9. So in the denominator I get 34. And the numerator, let's see, what am I going to get? I'm going to get 20 minus 12i plus 15i minus 9i squared. And let's see, so I hope you followed that. There's where I got the negative 12i from, and the positive 15i, and then the negative 9i squared. Let's see, I squared is -1 times negative 9 is plus 9, so that becomes 34. And then I got to subtract those, so I get plus 3i. Why did I say 34? 29, sorry about that. So 29 plus 3i squared. Let's see if that's an answer. 29 over 34. 29 over 34 plus 3 over 34i. I think that's the choice. So I hope that helps.